Good afternoon and welcome to NASA headquarters in Washington. I'm David Mould from NASA's Office of Public Affairs. Thank you for joining us today for our latest update on the Mars Science Laboratory mission. We have a lot to cover today before we open up for questions, so let me first introduce our speakers. First, we have the Administrator of NASA, Michael Griffin, Ed Weiler, the Associate Administrator for the Science Mission Directorate here at NASA headquarters, Doug McQuiston, Director of the Mars Exploration Program, also here at NASA headquarters, and Charles Alachi, Director of the Jet Propulsion Laboratory in Pasadena, California. We'll start with some opening remarks from these gentlemen, and then we will go to questions both from here at headquarters and from people who are assembled at the NASA centers across the country. So I'll now introduce the Administrator of NASA, Michael Griffin.
Thanks, David. Good afternoon to all of you, and thanks for joining us. Today we're announcing a delay in the launch of Mars Science Lab. Because of a number of factors that need to be addressed, we're slipping the launch of MSL to 2011. As many of you know, this mission, which is designed to assess whether the Martian environment is or ever was able to support microbial life, had been scheduled for launch in the fall of 2009. But because of problems principally with the rover's actuator motors, but also because of a rather extensive backlog of other work, we will not be ready to launch by the hoped-for date next year. Despite the delay, work on the mission really is progressing well, with the exception of the motor problem, which we just do not yet adequately understand. I have full confidence in the JPL team to be able to work through the difficulties, but we've determined that trying for 2009 would require us to assume too much risk, more than I think is appropriate for a flagship mission like Mars Science Laboratory. If we could delay the launch for a few months, we would, and that would probably take care of it. But launch opportunities for Mars don't allow that. They come every 26 months, and so we either go in 2009 or 2011. We're meeting with all of you today because we're aware that MSL has been much in the news lately. A mission like this ranks just behind a manned mission in importance, and we want to be straightforward and open with you when we have news to report, whether it's good or bad. So we look forward to answering your questions in just a few minutes, but first I'd like to introduce NASA's Associate Administrator for Science, Dr. Ed Weiler. Ed?
Thanks, Mike. Good afternoon, everybody. Let me put today's decision in context by taking you back to early October of this year. We had a major review of the Mars Science Lab, MSL, and the conclusion of that review, the JPL project and program and independent technical review team, was that we had a solid chance of making a 2009 launch if we could extend the launch window about 3 weeks, which we did, to mid-October, and if we could add about $200 million to cover the additional manpower to maintain schedule. We could have made the decision at that time to delay for 26 months, but making that decision then would have automatically added much more cost in the out years of the program. But, this is very important, we did not give an unrestricted go-ahead to launch in 2009. We put in place a major progress review with the administrator on January 5, 2009. Why that time frame? If we had not made sufficient progress to that point, we could then make the decision to slip, slow down the project, and live within the current 2009 budget, and thus not incur the additional $200 million in cost. But Mike and I went further than that. To ensure the goal of staying within that 2009 budget if we decided to slip, we had the project provide us with a series of milestones week by week in November and December that we could monitor weekly to judge whether we're making the required progress toward that January meeting. As of yesterday, the project, the program, the independent review team, and the JPL Independent Technical Authority all agreed unanimously that MSL could not make the 2009 launch schedule. This was based on slipping deliveries, new technical problems, and erosion in the schedule reserve. Mike and I accepted this advice, and we are going to rephase MSL for a 2011 launch. This will allow for careful resolution of any remaining technical problems, proper and thorough testing, and avoid a mad dash to launch. Failure is not an option on this mission. The science is too important, and the investment of American taxpayer dollars compels us to be absolutely certain that we have done everything possible to ensure the success of this flagship planetary mission. One of the questions I'm sure will be, what impacts will this have on programs in 10 and 11? We obviously haven't had enough time to fully evaluate that, but from the evaluation we've been able to do to this point, we don't think we'll have to cancel any programs in 2010 or 11, but of course there probably will have to be some schedule delays in programs. The impacts will come from Mars first, and if there's not enough in Mars, we will have to impact some planetary programs. When we work up those options, we will, of course, take those options and the impacts to the scientific community. We have an independent advisory structure here at NASA called the NASA Advisory Committee, the NAC. They have a subcommittee called the Planetary Science Subcommittee. We will take those options, those impacts, and share them with the community through that process to get their best advice. And we expect that to happen fairly soon. I don't have a timeline because, as I said, the decision to delay was yesterday. But we'll do that as expeditiously as possible. So to give you more details, I will throw it to Doug McKiston, who is the Mars Program Director here at NASA headquarters. Doug.
I'm going to talk a little bit about the technical and financial situations that have gotten us here, but first I'd like to set some context for the progress we have made on this mission. As Mike pointed out, we're really only a few months behind schedule, not 2 years behind schedule, but unfortunately planetary alignments push us into a 26-month set of opportunities, and that's the prudent thing to do here. So if I could have the first graphic, please. This is really 3 missions in one. This is a very complicated system. I know we hear the word complex and complicated almost overused, but I want to give you an idea of what that really means. This is the cruise stage. This cruise stage is probably on the order of 25 feet in diameter. This is what keeps the spacecraft alive on its journey to Mars for 9 months. This is probably of the class of an explorer's class mission all on its own. Quite a complicated piece of equipment. Next graphic, please. I'm going to scoot through these pretty quickly. This is the descent stage, otherwise known as the sky crane. This is amazingly complex. Typical spacecraft have propulsion lines that are roughly the diameter of a pencil. This has propulsion lines that are roughly 1 inch in diameter, and there's several gradations below that. So this is an incredibly complex, first-of-a-kind piece of equipment. As you can see, it's basically done, as was the cruise stage. This is probably a Discovery-class mission all by itself. It's quite a complicated piece of equipment. The next one, next graphic, please. This is the rover, which you can also see is largely assembled. To give you context on size, Jamie, who's the lead mobility engineer for the rover, is sitting in front of this, so you can see how large this is. This, and I'll show you in a second how this literally dwarfs anything we've done before. Why does it have to be so big? Number one, 2 years mission life on the surface. Number two, it's carrying a chemistry suite. It's a small chemistry lab, a pair of them actually, that are embedded inside this rover to be able to process samples and use the analytical instruments that are in it. You need a certain size and certain capability. And of course, it's a redundant system because it's a flagship mission. This is, again, a very complicated system, and Discovery class or better. Next graphic, please. This is called the stack. We have made, as you can see, an enormous amount of progress. This spacecraft is largely complete. There are a handful of items that aren't, but this spacecraft in that assembled configuration, the rover's inside the aeroshell, is headed into environmental test for launch cruise this week, as a matter of fact. So there, and that will continue. We want to understand and wring out that system as best we can before we go any further. Next one, please. This is our family, extended family, obviously. But to give you a feeling of context in size, you can see that Pathfinder was about 24, 25 pounds, carried a small amount of instruments. It was really pretty rudimentary. It taught us how to get to the surface and how to work on the surface. Spirit and Opportunity is to my left on that image. It is significantly larger, and we keep the same payload mass. Roughly about 10% of the overall system mass is payload. But when you move that to the kind of payload necessary to do the science that Mars Science Lab is going to do, you end up with a fairly large system of nearly a ton, as you can see. And I believe that's my last graphic. So the issues have really boiled down to the technical